Hey everyone, let's move into a mini lecture covering the completing the square method. So the completing the square method is for solving quadratic equations. There's several ways to solve quadratic equations. You could do factoring, square root property, completing the square method, which is this one, and also quadratic formula. So we'll focus on this one today. So there are steps to completing the square method, and I'll go through the steps while I'm doing a problem. But the first step is to set the equation equal to the constant. So it shouldn't be in standard form like most of the time. This time you want to move the constant to the right. You want to make sure that the leading coefficient is a 1. So if there's a number in front of the x squared term, you want to divide everything by that number. You're going to complete the square. So basically find half of that b value. Remember, it's in ax squared plus bx equals c form here. So in this one, you're going to find the b value and divide b by 2 and then square it. And then that value in step 4, you're going to add to both sides. Once you add that value to both sides, the left-hand side will be what we call a perfect square trinomial, and you should be able to factor that. The right-hand side, you'll just add the two values together. After such, it'll look like square root property form, which was covered in a previous video, so feel free to search that if you need a refresher. And then lastly, the resulting equation will just allow you to solve for x. So let's go ahead and go through a problem, and I'll go through each one of those steps as I go through the problem. So let's say we're told to solve, and the problem is x to the second minus 4x minus 14 equals 0. All right, so the first step says set one side of the equation equal to a constant. So that means move this negative 14 over. So we add 14 to both sides. So we get x squared minus 4x equals 14. The second step says to make the leading coefficient equal to 1 by dividing it to all terms if necessary. Well, the leading coefficient, as you can see right there, is already a 1, right? When there's nothing written in front of a variable, you know and I know there's an invisible 1 there. So step 2 is really saying if that were any other number, such as maybe a 2 or a 5 or a negative 8, we would divide everything by that 2, that 5, or that negative 8. Whatever number is in front of the x squared, you divide everything by that number. However, for this example, there's an invisible 1 there, so it's fine. Step 3 says find the value of half the second coefficient. Basically, we're completing the square. So as I said up here, use that b over 2. b over 2, and then we square it. So what's your b value? It's right there. So you use negative 4 over 2, and you square it. Your b value is always the value in front of the x. Negative 4 divided by 2 is negative 2. You square it. Negative 2 squared means negative 2 times negative 2, which is positive 4. All right, so we're on to step 4. Step 4 says to add the value from the previous step to both sides of your equation. Okay, so they're talking about this 4 right there. We're going to add that 4 to both sides of the equation. So x squared minus 4x equals 14. So we're going to go ahead and add that 4 right there and right there. All right. So now we're on to step 5, right? Step 5 says factor the perfect square trinomial. Well, first on the right side, I'm going to go ahead and take care of that. 14 and 4 is 18. And then I'm going to go ahead and factor this perfect square trinomial. Well, it should become the difference of two squares. All right. I'm sorry, it should become the difference of the x value minus that value that you had earlier. And that should occur twice, so I can write x minus 2 to the second power, right? So you're thinking, how did you get that? Well, if we were to have x minus 2 times x minus 2 And then if you FOIL that, you're going to get x squared minus 4x plus 4 back. Remember, first outer inner last? You'll get x minus 2 times x minus 2. So instead of writing it twice, I just write it once, x minus 2 squared. And also know that to figure out this number right here, it's always going to be that b value right before you raise it to the second power. So not the 4, but right before you raise it to the second power, it's a negative 2. That's going to be the sign and the number that always goes there for that step. All right, and then step 6 says use the square root property. So let's go ahead and use the square root property. So the square root property was covered in a previous video. Feel free to go and type that into the search bar on the Herbcon Education page and you'll come across it. So the square root property is x minus 2 squared equals plus or minus the square root of 18. And then we apply the square root property, the radical and the second power or inverses, so you're left with x minus 2 equals plus or minus the square root of 18. Looking at the last step, I'm sorry, let's go back up. We just solve for x. So to solve for x, you need to get x by itself, so we add 2 to both sides. So we get x is equal to, you don't have to write that positive sign if you don't want to, of course, but I just chose to show it just to make sure we're all on the same page and understanding that I'm moving it over, plus or minus square root of 18. And then you always want to do what? Simplify radicals, right? So x equals 2 plus or minus, and you have to say to yourself, what's the largest perfect square root that goes into 18 evenly? Well, the largest one would be a 9 that goes into 18 twice. So x equals 2 plus or minus. Square root of 9 is 3, so that comes out. That 2 stays under. And now you have your answer. X equals 2 plus or minus 3 times the square root of 2. All right, let's apply those same steps to another example. Next example is 9x squared minus 12x plus 9 equals 0. All right, so remember the steps. So the first step was to move the constant term over. So we have to subtract 9 from both sides, and then we get 9x squared minus 12x equals negative 9. If you go back to the steps, just go back a little bit, you'll see the second step said that the leading coefficient should be a 1. If not, you have to divide everything by whatever it is. So it's a 9 right now, right? So we divide everything by that 9 in front of that x squared. Divide by 9, divide by 9. So when we divide by 9, you get x squared, and that's what we want, a 1 in front of the x squared. Minus 12 over 9. Well, I can reduce it a little bit, right? I can say 3 goes into 12 4 times, and 3 goes into 9 3 times. So I can make it 4/3. And then this is equal to negative 9 divided by positive 9 is negative 1. The next step after this said to complete the square, use the b over 2 formula. Well, b is negative 4/3. That's divided by 2, and you square it. Well, think about what you used to do in arithmetic. Negative 4/3. When you divide a fraction by, we can call this 2 another fraction. We can say 2 over 1 if you want, instead of just 2. Well, when you divide a fraction by another fraction, what do we usually do? We would change it to multiplication and flip the other fraction. So we would keep, change, and flip. Right? So then once we do that, we multiply straight across. 4 times 1 is 4. 3 times 2 is 6. Then we square it. Let's see. We can go ahead and simplify that a little bit. 2 goes into 4 2 times, and it goes into 6 3 times. And then negative 2/3 squared is 4/9. All right, so we just completed the square. That step is complete. This next step says that you add that value to the previous line, right? You add it right here. You add it to both sides. You're going to add it right there and right there. So let's go ahead and do that. So we have x squared minus 4/3 x plus 4/9 equals -1 plus 4/9. So I'm going to go ahead and take care of the -1 plus the 4/9. So -1 and 4/9. Well, what is that going to be? -1, you can make it 1/1, but either way, you're going to have to rewrite your fractions. The LCD is 9 out of 1 and 9. This 4/9 is going to stay the same since LCD is the same. 1 goes into 9 9 times. 9 times 1 is 9. Or you could have already started from the beginning and said, okay, 9/9 means 1, right? So now it's -9/9 plus 4/9. So that's -9 and +4 make -5/9. So that right-hand side makes -5/9. All right, and then on this side, you should be able to make this perfect square trinomial into a binomial squared. That's what I was looking for earlier, that term, a binomial squared. Well, I think I gave you a shortcut earlier, and I said that it should be this value, right? This number that goes right there should be right here, right before you square it. So that's what it is. -2/3 goes right there. Because if you think about it, -2/3 times itself will get us the 4/9 that's up here in this trinomial. And if you add -2/3 to another -2/3, you get -4/3. All right, so that works. Okay, so the next step is to apply the square root property. So we square root both sides, plus or minus square root of -5/9. When we square a square root, they're inverses, so they cancel each other. So x minus 2/3 equals plus or minus. I'll rewrite it like this first. The square root of -5 over the square root of 9. And I'll show this extra step here. I like to show steps. X minus 2/3 equals plus or minus square root of -5 over the square root of 9 is just 3, right? And then we can say to ourselves, okay, that negative x minus 2/3 equals that negative underneath the radical. That tells us that we need to use an imaginary number. So plus or minus I square root of 5. And then this is all over 3. Now if I solve for x, I need to go ahead and add 2/3 to both sides. I'm going to add to this side here too. I'm actually just moving it over right up here into this space in front of the plus minus. But I'm doing it algebraically. So x equals 2/3 plus or minus I square root of 5 over 3. And we could keep it like this, but we might as well make it a little bit more clean. Excuse me, as you can see, they have the same denominator. So why not put them both under 3 and say 2 plus or minus I times the square root of 5 over 3. And then that will be your final answer for the completing the square method.